All right, welcome to Hoon School. One way or another, you have found your way here, and I'm excited to talk about the underlying system properties of Urbit, what it looks like to someone who is a programmer or developer, and how these manifest themselves in the way the system works and the origins from it. As an aside, I'm noticing in the meeting chat immediately some discussion about difficulty joining Hooniverse. I am informed that the planet is down today, unfortunately, which is absolutely wretched timing, but such is life. So we will get that back up, and I will ping you about it once again to get you involved there. My name is Neil Davis. I have been working with Urbit Foundation since last year on educational initiatives of various kinds. I enjoy teaching, and I enjoy Urbit, and I enjoy teaching Urbit quite a bit. So it has been my pleasure to introduce people to the way that Urbit works and what's involved in actually developing things on the system. The system is, while it has been in development for a decade at this point, depending on how you count things, in some ways it's still relatively immature, and in some ways it's quite mature. And what I mean by that is that as we work with the system, some parts of it will be extremely well elaborated. It will be very comfortable for you to get in and process data in certain ways. And I believe that it is a significantly faster development platform once you are comfortable working in the ways that Hoon and the Urbit operating system demand of you. But then there are a lot of other places where we need some work on the standard library. We need some apps that don't exist yet. And this also stands as an invitation to you to contribute in those ways as you develop these skills. Now, Jack, are you on? Tamlet Mod Nice. I cannot hear you if you are. He was having some microphone problems earlier, so it might be related there. Yeah, I could hear that.
Okay, great. Yeah, should I introduce myself?
Sure, go ahead.
Yeah, so my name's Jack, Tamlet Modness on the network. So I'm going to be TAing under Neil / co-teaching some of the courses. I'm super excited. It's the first time for me, and I'm super happy to see the huge turnout. So yeah, I hope this will be a good run. Some background on me is that I was in a computer science PhD program, and after learning about Urbit for a while, I decided to drop out and spend my time on making this a real thing. I was actually in your shoes just about a year ago, taking Hoon School live, and since then I got involved in hackathons. I've been in the development of 2 apps. I'm just getting more and more involved in the ecosystem, and it's been a really great time. So yeah, I'd love to see that happen for all you guys, get the pipeline going and getting people involved in things that they want to do. So yeah.
Award-winning apps. You should inject when you do that. Yeah, it's been great to work with Jack on this. We are going to teach Hoon School in 8 lessons. We are going to record these sessions. We are going to post them, share the lesson notes with you. There will be a homework that is associated with each lesson. We will grade and get you some responses on the homework, but completing 7 of the 8 homeworks is our requirement for being counted as a Hoon School finisher. Hoon School finisher means that you get a shiny digital badge and you get the pride of saying that you've done it, and not a whole lot else at this point other than the knowledge that you will acquire en route to doing that. But it's a way that we do have of tracking what you've learned and sort of your participation in this ecosystem here. I will try to remember, this is a new feature that I'm going to be adding here, where I want to take the last 5 minutes of every lesson and open it up as a Q&A to make sure that we cover lingering concerns or issues that arose during the main lesson. And we're also going to send you a quick feedback form for each lesson with a single question just on how things worked for you, what worked well, what didn't work well, just some feedback along those lines. I am interested in actively improving these. I have made significant changes to Hoon School every single time I have taught it. And I write too much, so there's probably way too much text if you take a look at the lessons, but hopefully between all that, we will be able to get you through this. Your background coming in here is pretty varied. Some of you have not programmed before. Some of you have years of professional programming in various languages. Hoon as a language is it is built to run on the Nock virtual machine. Nock gets described as the operating language of Urbit sometimes, but you can really think of it as a specification. It's basically the sort of the mathematical language that any Urbit system is actually running. And so when you open an Urbit ship, you have Urbit on hosting, you've run Urbit on your own machine, whatever the case may be, you'll typically interact with it through a browser. And that browser will look something like this. Let me see. Unfortunately, Zoom has a tendency to hide everything that it is over the top of on my screen. So please let me know if black boxes obscure anything you need to see. But this is what you will see when you're actually running Urbit and you're interacting with it as a regular user. These represent different applications running on your Urbit ship. These are not all of the applications running on your ship, but these are all of the applications that have registered that they have a front end and that they expect you to interact with them through a browser. Like many other programs that you are going to run and deal with through a web browser, Urbit is essentially running as a server or a standalone program somewhere. It might be running on your own machine. It might be running on a native Planet unit. It might be running on the cloud. It might be running on hosting. And you are interacting with it through a web browser as one of the ways of interacting with it. It's not the only way of doing it, but it's probably, it is definitely by far the most common way that people are going to interact with an Urbit ship. We're going to call it a ship, which is kind of an older terminology, but that means the actual Urbit process, the Urbit program, wherever it is running. What I would like to do with you is we're going to mainly work on the command line. I sent a note earlier today about what that would look like as far as installing Urbit, getting it to run on your own machine. If you're running on Linux or Mac OS, there is good support built in for you to be able to run this directly at the terminal window. If you are running on Windows, your current best solution is to use the Windows subsystem for Linux, which will give you a Linux-like, well, it'll give you an embedded Linux system that you can use directly inside of Windows to access Urbit and run things that way. I hope that most of what I'm going to be doing in the lesson will be interactive in that you should be able to follow along. And if things aren't working correctly, you'll be able to drop questions in the chat or unmute briefly if it's a quick thing, and we can try and work you through all of those issues as those come up. That said, let's go ahead and actually open up a terminal and see if we can get Urbit running for you on your own machine. Now, I am looking for, Urbit does this sometimes, or sorry, Zoom does this sometimes where it doesn't show me the window that I'm looking for when I attempt to share my screen. Okay, let me try closing things and reopening them and seeing if Zoom gets the picture. There are a lot of things I'd like about running on Linux, but Zoom tends to be rather buggy, unfortunately. Okay, let's see. You should see a terminal window here that is variously hiding and not hiding content as I'm moving things around on my screen. Let me get the chat window open so I can monitor anything you have to say as well. All right, let me go ahead and set this up really quick as a screen that we can all see. All right. Now, conventionally, when you go ahead and run, you're working on the command line. This is the regular command prompt, command line terminal, shell. I might use all of these things interchangeably. They basically mean that you're running terminal on a Mac, command prompt on Windows, except it's whatever the Linux version of that is through WSL. This is where you would be able to type commands like ls or cd. This would be your conventional Unix commands. What we are interested in doing now is being able to run Urbit. If you run Urbit by itself, it will, in my case, it'll fill up the screen because I'm zoomed in quite a bit, but it'll give you some information about what it looks like to run Urbit. If you have followed or will follow the instructions at urbit.org/getting started, there should be some command line or CLI instructions linked there. And that should get you to the point at which you are able to run this Urbit command and work with things. When you run a conventional Urbit planet, you've acquired a planet, you've acquired a star, you're going to run it, and it's going to be working on the live network. You'll run it. Maybe it's running on the cloud or some other way that you can just leave it running and you can forget about it. You can interact with the web browser. You don't need to worry about it. We are not going to work on the live network when we start programming with Hoon now. We are going to work on what are called fake ships. And we can create a fake ship by doing Urbit-F, capital F, and then the name of the ship that we wish to fake, the ship that we wish to create. Zod is the basic galaxy that provides it's the source for the operating system and everything else that's going on in Urbit. By convention, typically, when we're working locally, we're just going to go ahead and type Zod and just work with Zod. So your command in this case would look like Urbit-F, Zod, capital F, lowercase f may do nothing and it may do something else. And when you do this, it will go ahead and it will start to boot using whatever Urbit system you have installed. If you've installed Urbit today, you probably are running Urbit version 2.1 or 2.0 or 2.1, but your process will look basically the same. And there's nothing we're doing that has any differences in Hoon at this point, so there's nothing to worry about with respect to which version of Urbit you're running here. It's going to give you some stuff about downloading what's called a pill, which is your boot instructions. It's what it's using to actually build this. And then it's going to tell you that it's replaying the events. This can take a little bit of time. So I'm going to go ahead and Control Z to terminate that process. So Control Z would stop that process. You don't need to. I'm going to because I am teaching live and that takes a little bit of time. So I'm going to remove the one that I just had, and I'm going to copy Zod copy to Zod. And now I should be able to run Urbit Zod. And once I'm able to do that, I will get what's called a dojo prompt. This is the main prompt that Urbit will be running. It'll say dojo. This is Urbit's internal shell. This is what happens when you run an Urbit directly, whenever you're interacting with it. You can type Hoon commands here and it will execute them. You can also type a lot of other things here and it will execute them as well, system commands and so forth. So you have all of these things available to work with here. Now, I believe, although I've spent the last 16 minutes not living up to this belief, I believe that it is important to get you to writing code fast. If you were able to, in response to the question in the chat, If you were able to get Urbit running earlier from the commands that I sent out, and you're able to boot a fake Zod, a fake ship, then please follow along with me. If you were not, then come to office hours later this week, and we will get you squared away and running and ready to do everything. So right now we're going to focus on some conceptual things. We're going to be writing some code together, but don't sweat it today. We'll get you squared away this week, and when you come back next Wednesday, you'll be ready to write whatever you need. All right, our first command, we're going to write this symbol here. It's a percent and a hyphen, 2 spaces, the word add, 2 spaces, and then a pair of values 5 and 6. And if I press enter here, you can see that it returns the value to me of that Hoon expression. I posted this in the meeting chat as well. People have had mixed luck in copying and pasting code from Zoom. Sometimes if you click on the 3 dots to the right of a chat entry, there's an option to copy, and it will correctly copy with the spaces, but it often trims out spaces. And since Hoon makes a distinction between single space and double space, it will break things in interesting ways if you just copy, unfortunately. As we have longer code snippets to share later on, we will deal with that proactively. So, all right, what did this do? Okay, you know, this shouldn't be a mystery to you, what this line of code did, but you know, go ahead, humor me, describe it for me. What did this line of code do? And you can unmute or you can type something. I'm not picking.
Added 5 and 6.
All right, so it added 5 and 6. If we'd like to get more technical about it, it did something like look up the name add, which was some kind of operation, and then it applied it to a pair of values that were associated with this operation. Now, in standard mathematics, you know, we would like to write something like 5 plus 6. So I'm going to call this standard notation. This is what everyone's comfortable with. You know, you can write down 5 star 6, 5 plus 6, whatever you have, and people will be, you know, you know what it means. You can look at it, you know what it means. If you've worked with scientific calculators before, in particular the HP56 series, you may have run into notation like this. Okay, this is what they call reverse Polish notation. And in this notation, you put the values, the operands, the values on which you are going to operate, into the system first, and then the operator that will operate on the previous 2 entries will pull those off and yield the result for you. It's the same operation as the first line, as the standard notation, but it looks a little different. We write it differently. If some languages would prefer to say it something like this. Okay, so they might have like an add operation that looks something like this. A Lisp language. A Lisp is a family of languages from the 1960s that's very formally mathematical and has some relationship to Hoon. It would look like this last line here. And all of these are carrying out the same mathematical operation. We're just taking advantage of flexibility in the way that we're expressing this concept. This is something that you will get used to as you work with Hoon. That and indeed, every time you learn a programming language, you're doing this to some extent. You know, many programming languages like Lisps, they don't look like standard 5 plus 6 notation. A language like C, C++, Java looks more like 5 plus 6 for arithmetic. But many other languages don't. And so that's something that you would have to get used to as you look at doing anything on a computer here. If you've ever worked with a computer algebra system, and, you know, of course, I'm not requiring or suspecting that you have, the way that they commonly think about these values is that there's a tree showing how an operator relates to its operands. So in this case, I'll just label this operator. And these are the operands. And then altogether, I'm going to call this an operation, right? It's a particular case in which we carried out this value here. And we can do this at different levels. So if I were to write something like 6 equals 4 plus 2, an equation, then I might also be able to say something like 6. Let's see if I can do this right. All right. So I could have something that looks like this tree expression at the bottom here, where there's a left-hand side of this equation operation, this operator with this equals sign, and there's a right-hand side, and that right-hand side is itself composed of a sub-expression. Hoon is going to lean very heavily on this kind of this understanding of what's going on with expressions. Whenever we want to write something down on a computer, at some level, we can draw a map of it to this form of thinking of an expression as a tree. We call this a tree in programming. It doesn't look exactly like a tree, but we'll give it to them. It's close enough. It branches. It has parts of expressions that branch into subsequent entailments of these expressions. And so when we wrote this expression up above in Hoon, and if you press the up arrow, you can cycle back through to previous operations. We can do things like change the operand and get a different value. Or we can change the operator that is being invoked here. In this case, I'm changing it to mul, which would be multiply. And now I'm evaluating 5 times 8, which of course evaluates to 40. Now you'll notice that every operator that I've written down here so far has 2 children. Okay, there's nothing that they would have to have 2 children, but every case that I've shown you thus far does in fact have 2 children. And so if I go back up here to 5, 6, and I want to say, let me say that I want to add these values together, 5, 6, and 7. It's going to give me a somewhat obtuse at this point, although you'll be able to read this fairly soon, a somewhat obtuse error message. And it tells me that it's expecting 1 @ symbol, but it has 2 @ symbols. And in general, Hoon expression failed. It failed to evaluate whatever was going on here. So what's happening? Coming back down here to the bottom, I'm going to make the Hoon operators explicit. I'm going to try and do this by copy pasting because I already got the spacing right, and I think it's more beautiful this way. Let's see. So what's actually happening, and I gave you a little bit of a simplification there at the beginning, which is I can also do something. So %- did something, and we hinted that it loaded a name of some operation, and then it loaded the values of this operation, and then it did this operation. So we can think of %-, what we'll call a rune in Hoon. This is like a keyword, but it's a symbol, right? We'll think of this symbol as simply saying, apply this name, this operation, this operator to these operands. So you give it an operator and you give it operands, and this is where your expression in Hoon comes from. Now, where I simplified things just a little bit was I wrote 5, 6 this way. That's actually a shorthand writing. And normally, if we were being fully explicit, we would write :-, which builds a cell of values. It builds a pair of values. So it accepts 2 values as its own symbol. It accepts 2 values. The left-hand value is a single number. The right-hand value is a single number. And it puts them together into a cell, right? 2 values that are united as a pair of things. And then once you have this pair of things, you can do other things with it, like you can apply multiplication to it or apply addition to it. Hoon is always going to work this way. It is going to have something that is a rune or a symbol. We're going to call them runes. So terminology we have RUNE, long may it live. It does just fine, but essentially these are keywords that describe how expressions are built in Hoon. And we're going to go way, way, way deeper into the rabbit hole with this as we go farther on. But at this point, we need to think about what we're actually saying when we say this expression here. Let me write this in a slightly different way down here. See if I can do this right with my spaces. I'm saying there's an add and there's a 5, 6, right? So I'm looking at this entry right here. And I'm also implicitly saying that that is also equivalent to the second tree here, the second expression, right? Because the right-hand side of this expression, this 5, 6, is itself built out of a sub-expression of this colon and this hyphen. So it's an extremely formal way of thinking about building expressions here. And it does this because the underlying mathematical specification that we'll be following, that we'll be building things to run on, which is called Nock, also has a discipline that is similar to this, or at least a discipline to which this maps well. And so every Hoon expression that we're ever going to build ultimately will boil down to these kinds of expressions. This is very powerful. There are some interesting ramifications of this, which include the fact that if I would like to add 3 values together, let me do this all in one line. All right. I wrote a line there. It's a little bit of a monstrosity. We'll write it in a little bit clearer of a way in a moment. What is that line really saying? Sorry, I'm trying to move Zoom out of the way so I can monitor you a little better here. There we go. All right. So what is this line actually saying? If I were to draw this as a Hoon tree, the way I've done everything else, it would look like this. Yeah, so we're actually, yes. So first add 6 and 7, later add that to 5. And so there's an interesting phenomenon where we actually have to read this expression that we have here right to left, right? We have to resolve what you can think of as the deeper parts of the tree first before we can resolve the parts that apply to them. So if we write the expression like this, we can think of it as we have to read it a little bit right to left. It's a little bit odd. You'll get used to thinking in this tree-like structure of branching expressions joined by operators. But we're going to work with this as we keep doing this. Now, at its root, I've mentioned a couple of times here Nock, right? Like what's going on with Nock. So at its root, the Urbit operating system has this contextual model that is built on this formal language that is essentially a mathematical machine language. And so an expression in Nock would look like this. All right, and you can go look up what the Nock specification is. And you can look at what rule 8 is, and rule 6 is, and rule 5 is, and rule 1 is, and rule 9 is. And you can learn to read Nock. But you essentially never have to, right? It's not a thing that you actually have to break down and do, because you're always able to write Hoon, and Hoon maps directly down to Nock. So Hoon is going to serve as Urbit's practical programming language. And we don't have to think about the Nock level, which is analogous to writing assembly language or machine code, except that there are cases in which you want to write assembly language, like if you're doing a device driver or something. There's basically never a case where you as a developer of user code will have to write your own Nock. And so you're going to work in Hoon. But a lot of the interesting properties of Hoon, the way that these tree expressions and so forth are built, is essentially it is the way it is because of the properties of Nock that it is built upon. Now, let's see, I am halfway through, and I think we're okay time-wise. Okay, so there's different kinds of things that we're running into as we look at this program here. So we can think that there are things that are Hoon operators, that are runes. There are things that are the names of mathematical operations. There are single values, and then there are things that we have built into cells or pairs of single values. And it turns out we can actually build pairs of pairs. We can keep separating everything. So in this case, there's a cell 1 and a cell 2 on the left-hand side of this tree, and there's a cell 3 on the right-hand side. You can get deeper into this. The most general data category in Hoon is what we're going to call a noun. This is about as broad as saying a thing, right? Like it doesn't really get us anywhere. But there are two kinds of nouns, and this does start to take us somewhere. So there's one kind of noun is an atom, which is a number. Ultimately, it's a non-zero integer number. So everything in Hoon is either an atom or it is a cell. It is a pair of numbers. And this cuts a little bit against what I seemed to be saying to you a moment ago, but I'm going to come back to that a little bit more. So if I were to type a bare number, 729, press enter, this is a complete expression. It's an expression that just looks like this. Like it's sort of a trivial expression, but it is an expression, right? It does something all by itself. If I were to write a pair of values together like that, then I have generated a cell. And so a cell can be a pair of any two nouns. And so it can contain atoms, it can contain other cells. All cells and atoms have the same structure, and they're going to display similarly, even if they're much more complicated than these. We can build up things that are more complicated. Now, if I just told you that everything in Urbit is either an atom, which is a non-zero number, or excuse me, a non-negative number, or it is a pair of numbers, how do we represent anything? Like, what do we actually do? Like, how do we do this? So Hoon has an interesting feature. We actually have this problem in every programming language of how do we represent a value. Hoon is going to expose what is called an aura, and you can apply this to any value. And what it's going to do is it's going to change basically. We're going to call it the type, but it's basically the way that the system thinks about the number. So in this case, I did a tick, which is the character above the tab key at the upper left of your keyboard, a tick, an at, and then a UB tick. So this, you can think of this as kind of like a sideways quoted at UB. This converts whatever number is to the right of it to an unsigned binary number. All right. And so you were able to see what the binary representation, the representation only in zeros and ones, what this number would look like. If I were to change this to UX, this would change it to hexadecimal, and this would give me the hexadecimal equivalent of this statement. If I were to change it to T, then it would give me the text representation, and you'll notice there are two single quotes next to each other. So this is what in programming languages generally we would call a text string. And this is a space. So this is the ASCII code for the space character, the space symbol is 32. And if I apply at T aura to this, aura, A-U-R-A, then this functions as basically a type marker for atoms. And there are a lot of different type markers. There's a date type marker. So I can type some value here, like 100, and it'll give me a date. And it turns out that this date is 292 billion years in the past, just based on when the date system starts. So, you know, we'll get into that much later on when we look at the way that these numbers are built. It turns out as well that you may have heard people refer to on network to your PAT-P. In Hoon, we have a canonical pronunciation of every ASCII symbol. And you know, if you're actually trying to say things, and it's a little bit cumbersome to say, well, then there's a hyphen and then an open parenthesis and then a closed parenthesis and then an @ symbol and then a hash, these kinds of operations. So they decided to just go ahead and standardize the pronunciation of everything. The standard pronunciation of the @ symbol is PAT. And so your PAT-P is your planet name, or excuse me, or your ship name. So my ship, for instance, is Lagrav Nock. And one of the neat things I can do is I can also turn this into something else. So what is the number that Lagrav Nock corresponds to in the address space? That's 4,235,396,352. I probably can't convert this to text because this isn't like a well-defined text character. So it gives me an error there and it says bad text. So, you know, if Hoon is unable to do something, it will kindly let you know that it's unable to do it. Now, what we're doing with cells then is we're able to build cells out of any two other things. And I can actually do it out of even types. Like I can write a cell of PAT-P and PAT-T, and you'll notice that it did what I'll call a scroll back there of a bunch of other information that are just different parts of the system that we'll dig into as well. And so we're able to build more complex cells. I could do, we're going to pronounce this COLHEP. Colon hyphen would be pronounced COLHEP, COLHEP. So let me give it a 1. You also notice that if you're, one of the frustrating things about working with the dojo is that the dojo will not let you type code that is invalid Hoon. So if I were to type COLHEP single space and then attempt to type the number 1, dojo will simply do nothing. It has nothing to say. That's not valid Hoon, because runes operations, runes and the values they operate on must be separated by 2 spaces or more in Hoon, simply part of the syntax of Hoon. Now, something I didn't show you earlier when we were looking at these names with what we'll call senhep, this is the apply operation, the apply rune, is that other than 2 spaces, I can also put a line break. So I can press enter, and then you'll notice that it goes to a left-hand facing prompt. This is the continuation prompt. So it's waiting for me to give it more information. Senhep, yes. CENHEP is senhep. It's not critical that you learn these, but since the documents are sent up to search this way, and everyone is going to talk about them this way, you're going to save yourself some time and trouble to just have a standard set of names for calling everything, something in particular. So you'll see what I've done here is I've taken this expression that I had done in 1 line before, and I've broken it into 3 lines. And in some cases, this can make your code far more legible. So for instance, consider this expression. All right, so here I broke things up and showed it to you here, so you can sort of see like how the cell parts are built. And this is slightly unfortunately, the pretty printer, the printer that displays these, hides cell brackets on rightward branching cells. This does make things cleaner later on, so you don't have a zillion closing brackets, but I don't like it when I'm teaching Hoon for the first time because I feel like it's missing a little bit of information that it needs there. Now there's a question, is there a page for these pronunciations or an easy way to get the name of a rune while in the dojo? At one point in the past, there was a way to get this information in the dojo. Yeah, that's not doing what I would have hoped there. Yeah, it's not doing it anymore. Now what you'll need to do is you'll need to go to the reference page that Bantus Follows just linked for you, and that will have the standard pronunciations for everything. You don't need to go get flashcards or go do anything fancy with these. A lot of these, you can look them up if you need them, or you will pick them up as we go through Hoon School, and I will say them verbally whenever I type them, and you'll be able to work through them. All right. Now, when we build anything on Urbit, and in fact, your entire Urbit system itself, it is a single Hoon expression that different parts of it are getting evaluated at different times. It is a noun. Your entire system is a noun. Everything in Nock, everything in Hoon is a noun. Every program, every application you write on Urbit is ultimately going to be a complicated expression. These rules that I just taught you apply all the way from the top to the bottom. You don't know all of the runes. You don't know all of the ways to use the runes. That's okay. We'll get to that later. Well, we won't get to all of them later on, but we'll get to more of them later on. So the backbone of any Hoon program, any Hoon expression, anything that you're doing is going to be a scaffolding of runes, which are like your verbs. They're like your grammar. They're like your mathematical relationships between the daughter components. They describe how the nouns relate to each other. So earlier, when we called a function, we used the senhep rune. We gave it the name of something as text, so it knows to go look this up in the system and see, okay, do I know about a name called add? We can try it with the name that doesn't work in a moment. And then I give it, the other daughter expression. It expects, senhep expects to be given a function on its left hand, and to be given the values to which that function applies on its right hand. That's all it expects. It's actually add that expects precisely two values. Not every operation does. So if I run this here, it goes, looks up the name, grabs the two values, brings everything back. There's another operator called dec that expects one value. So what does dec do? I gave it an 8, it gave me a 7. Yeah, so this is a decrement or a decrease operator. Subtracts 1 from whatever I had. If I try to give it something else, let's see what happens. Okay, now it tells me that it's the wrong shape, and it sort of looks like the error that I had before. What it's actually telling me is that it needs one atom, one single input value, but what it actually received was a cell of values. And it's also giving me the additional information that these are unsigned decimal values, which is their default value here. So there's a question here, can I combine the decrement operator with a cell? Not directly. There are ways that I can modify it to apply to a cell, or that I can build an expression which would apply it one at a time to each element of a cell and result in a cell of those values. And we will explore basically short expressions, very short programs, code snippets that would do that for us. So we'll head in that direction later on. But right now, what we're seeing is senhep, the apply operator, the apply rune, actually doesn't care what the two values it's being given. It simply says, give me something on the left-hand side, give me something on the right-hand side. I'm going to jam them together. I'm going to see if it works. And so if I give it something that doesn't exist, all right, so I give it a set of values there, and a set of values here, then it's going to crash by telling me that it can't find the name on the left-hand side. I'm going to refer to this as the left-hand side because I'm thinking of it in the tree expression from below, even though I'm writing them on multiple lines here. All right. So that's what's going on as I build these kinds of operations. Now, there's really no limit to the complexity of Hoon expressions. We can build expressions that are deep and wide and built with different kinds of grammars and everything. One way I could do this is kind of an interesting one because there's a lot of flexibility here, is I have my senhep here, I give it add, and then I give it a cell in which the left-hand side is this parenthesized version of senhep, looks a little different. And then the right-hand side is the 3. And so it's going to add the 1 and the 2 together first, and then it's going to add the 3. As an exercise for the listener, draw on your own time, draw what this sort of binary tree would look like from this operation that I did right here. All right. Shouldn't be too hard for you at this point, but feel free to come to office hours. We are infinitely patient to go through this with you. I just pasted is why it showed up with just a single prompt there. So if you're going to type something like a colhep in this case, you can press enter and it will go to the continuation prompt. This is because Dojo recognizes that you have not given that rune the number of children that it expects. If you press enter again, it will terminate attempting to evaluate that rune and return to the regular prompt. Okay, so that's what's going on. We are pressing enter in between our lines here. And then when it has the correct number of children for that rune, it will evaluate the expression. Now, not every expression has 3 children. Not every expression returns a single value back. So you can kick things around and do things in different ways here. Yeah, so Python's interesting because Python is very rigid in the white space construction of expressions. The type system is also extremely different from Python, and that one will get you in some trouble because Hoon is very strongly typed and has very strong opinions about how to put things together that will have some interesting ramifications for us later on. But like Python, there's a lot of possible ways to express code, and Hoon definitely shares that kind of flexibility in producing expressions. All right, so any Hoon program that we build is going to be architected around runes. We're going to use runes as the backbone, as I said. If you've used another programming language before, you will see these as analogous to keywords. If you have not programmed extensively before or at all, think of them as mathematical operators, things like an integral or solve for x or something like this. They make explicit what a lot of language syntax parsers leave implicit. Hoon strives to give you a unique characteristic way of writing a correct expression, but it leaves you a lot of flexibility in how you lay out the components so you can maximize readability as you write a program. So you will see that people have a lot of freedom in the way that they decide to structure even equivalent Hoon programs. It's kind of fun to go ahead and do that. We have only introduced a small handful of runes in this lesson. There's senhep and colhep. I think that's basically the ones we looked at so far. By the time we're done with Hoon School, you're going to know about 20 or 25 runes. That's going to be 80% of the Hoon that you need to write. Okay, like there really is a good 80-20 rule here. There's probably somewhere north of 100 runes at this point total, but many of them do 1 or 2 specialized things that are necessary in the system kernel. They're not things that you will ever need to run into in particular, but we'll see them from time to time. Now, let me see if I can, let me do something scary. All right, let me do something scary. So don't follow along with me right now. I'm going to open a random program from Hoon. Let me see what I want to open here. This is crazy. And okay, this is fine. All right, this one's not too bad. All right. Now, I don't expect you to understand this code. and that's fine. What I want you to do is I want you to look at this code, and knowing what you know about Hoon now, only with what we've seen, you ought to be able to identify different pieces of what's going on. So for instance, what is this pat UD? Right, like what kind of thing is that? All right, so it's so the pat UD is an unsigned decimal. The pat DA is a date. The pat P is a name, like a ship name. All right, we know what a COLHEP is, right? What did the COLHEP do for us? There's a COLHEP here. COLHEP wasn't assignment; it was a cell, right? It was a cell for us. We don't know what some of these others are, but we can see that there's a rune structure to what's taking place here. There's a dot ket. There's a tis. That's this equal sign. An equal sign is a tis. This is a dot ket, or a dot caret. We can see there's a bar tis. This defines a function. So this is a function creation here. Would anyone like to hazard a guess at what col is doing here? All right, so these are comments. These are expressions for you, the developer, to remember what on earth you were thinking or someone else was thinking, excuse me, when they came up with this clever code. They're ignored by Hoon. They're not part of Hoon. So anything you begin with a col to the end of the line is ignored by the program. So you can use that to annotate what's going on and explain your rationale. These texts that start with sen, right here, sensei, this is a kind of text. It's a different kind of string, basically, but it's an encode string. These are cells right here. They look a little different. They're cells. There's a fair amount of irregular syntax in here, and we're going to start with regular syntax in Hoon and introduce irregular syntax slowly. There's a lot of irregular syntax in Hoon. Ultimately, it does make things more legible, but it will take us some time to get there. Question in the chat: is it fair to say that a cell is akin to an array? That very much depends on what you mean by array, since different languages can think about that very differently. A cell is a pair of two values. If you had a cell of a cell of a cell of a cell of a cell, you can treat that as a list or a tuple or an array, depending on just kind of the operators you want to attach to work with it. And we will do those, but the cell is the most basic idea. Another question is the statement following after the bar tis, this statement here, the parameters. Yes, this is the input arguments, the input parameters. Unfortunately, because I picked what's called a say generator that we will talk about in the last Hoon School lesson in 7 weeks from now, this is a particularly complicated example of that, but you will be able to interpret it 7 weeks from now, so you have something to look forward to there. Anyway, I don't want you to get distracted by like what this code is. I happen to think that this looks really cool and that Urbit is the most cyberpunk programming platform just because the programs you write look like this. But when you're able to read and write code that looks like this, you will find it to be very expressive, I believe. So I will leave you with some examples where you can step in and see what's going on with particular values here. Now, there's a little bit more code about giving names to things and what different programs could look like. Let me run that briefly by you, just because I do want to show you how to preserve names for things. So this is a tisfaz. This is how I give a name to a variable. And then I'm able to use that name subsequently in my expression. So in this case, basically, I'm giving a name to the value 28. So tisfaz was what we would call pinning a face, giving a variable a name. And then once I've done that, I can use it in subsequent expressions to do this. Now, one of the odd things about this is that that name only exists in the expressions that are subsequent to that name. This is powerful. It gives you a lot of latitude in naming things because you know you're not going to have to worry about only using a name uniquely in one place the way you might in a language like C or Python. But it also means that if you forget where you are, you might lose the variable. I can't refer to perfect number outside of the expression in which I defined perfect number. And so that program that I just wrote would look something like this. Where Tizfaz, you may notice, how many children does Tizfaz take? It takes a new name, which is a bit of text that I made up. It takes a value that gets associated with that name. And then it actually has a third expression, a third daughter of the rune, which is whatever else I'm trying to calculate, right? It's the rest of the program. And so when you read expressions as you go line to line, you often just have to recall that each line, each rune, there's kind of an implicit next child that is the next line until you actually get to a value. And once you get to a value, then that returns back up the expression, and you're able to build the statement this way. Something to get used to here. Let's see, there's a bit on cells and text. I will leave that with you in the notes and maybe talk about it a little bit more next time, but we're at 9:28. So let's see, very briefly, let's turn it to Q&A, and I see there are a couple of questions in the chat I will get to in just a moment. And then I had that feedback question, the feedback question I was going to try this time. So let me find that and paste it for you. And it's anonymous. You can just tell me, hey, this worked for me. Hey, this didn't work. Here's what I'm still confused about, and so forth. And it is fine to be confused at this point. Although I believe that if you have gotten this deep into the system, you are capable of learning how Hoon works. Like much like an advertisement, if you see an advertisement, it's meant for you. If you have made it to Hoon School Lesson 0, Hoon School is meant for you. But, give me some feedback there. And we're going to have office hours, but we're also often hanging out in Hooniverse once that's back up, and in the Urbit Gather instance. So you can drop in as a guest there. I have sent and will send the link again to join that. All right, some questions that I want to hit here. Are Hoon data structures immutable? Yes. You are creating an unchanging data structure every time you write an expression. And when you want to change it, you're actually creating a new one and then just interacting with that new one rather than with the old one that you were working with before. And then this is all done in memory. So, when the expression is done and it finally results in a value, it can throw away all the parts of the calculation. It doesn't need to hang on to those. To start with a fresh Zod, if you delete the Zod folder, yes, then Zod is gone, and you can start over again and just deal with that. It's getting much harder to really mess up a fake ship than it used to be, but we still are going to stick with using fake ships for the time being. Don't do it on your live planet. There's a growing cohort of people that are doing it on their moons, which I think is actually a pretty good solution, but we'll stick with fake ships for now. Let's see. There's a question about Hoon garbage collection I'll address in just a moment. I'm assuming it's not okay to do these practice lessons in the landscape terminal in case we mess up our planets, right? I would recommend not doing it because sometimes you rename something or you delete something that you actually wanted to be pointed in a certain place. It's a little risky. And since your Urbit digital life is on your planet, I would teach it. I would treat it a little bit more safely than that. But a moon is fair game. You can do it all day long in a moon or a comet. We will send the recording link. There will be a homework and some reading. So I will send you the lesson notes that I worked from today. They are a little bit more extensive than what I was able to cover in the time I had. I think that's fine, and I think you'll be okay. But again, drop in if you have any questions. And then there are some suggested readings in the docs if you would like to know more about it. There has been some discussion about doing a Hoon book, but we are currently of the opinion that the system isn't quite settled enough to make that the time investment we want to do there. Let's see. The other, I'm not going to say recommend learning another language alongside Hoon. If you have a background in OCaml or Haskell or Erlang or another functional language, APL is a really good one. That would be helpful, but I wouldn't say go out and learn this at the same time. JavaScript is very pragmatic because honestly, we always need people who can write decent front ends in Urbit. Let's see, other questions. We will get your recording link once I have that up. There's a question about garbage collection in Hoon. So Hoon actually uses an interesting memory model called the road, where every time you build a subsidiary calculation, so in conventional memory, and if you don't know what this is, like fine, zone out for a second, you have your heap and your stack. And they're used for different kinds of calculations. And generally speaking, heap is considered the memory that's more persistent in your RAM, and stack is more ephemeral. But then as you do a subsequent expression, you actually put the heap and the stack for the next level on the stack of the level below it. And then on that stack, you can put a heap and a stack as well. And you can kind of do this interesting mapping of persistent data structures up and down through the heap and the stack as you do it. And a lot of Hoon data collection, garbage collection is naturally handled by simply retiring the inner loads. That's getting very deep into the way that the runtime is actually building it. It's not a feature of Hoon, it's a feature of Ver, which actually runs your Urbit ship. When we run, Urbit at the command prompt, that's what's running. It's pretty fascinating. Dig into it, have fun with it. Let's see. In the examples, I didn't assign the numbers in ERA, but Hoon just assumed the numbers were numbers, right? So a bare number gets the default ARA of PAT-UD, which is unsigned decimal. If I'm typing a number, it's an unsigned decimal. Yeah, so add assumes that it's getting two atoms that are, a cell of atoms, which are something that it can work with. It can actually do things other than unsigned decimals. Are assigned elements within our system accessible system-wide? If I create a name cell on my planet, am I able to provide someone else? No. There are ways to expose data to other people, but it's done in a pretty principled way of exposing endpoints so they can access particular instances of value that way. The Hooniverse site, HitEvDanet/new Hooniverse. HitEvDanet is the planet. It is down today, which is terrible timing, but we will get it back up soon, and I will send you more notes there. All right, and I'll give you one more question, and I'll wrap because we're at 9:35, and I don't want to keep anyone too long. The examples I didn't assign the number. Oh, that's the same question I just saw a second ago. Can we debug a Hoon program step by step using something like GDB? No, not really. Okay, so you can use GDB, GNU debugger, with the Urbit runtime, but it's actually looking at the way that things are getting interpreted into machine code and run, and it would not be helpful for looking at Hoon at all. We can get a good stack trace if a crash takes place in a Hoon program, so we can actually see where things broke and what it was trying to do when things broke. But we do not currently have a debugger program that would let us pause at particular breakpoints and continue to run things. It would be fantastic to have, but we don't have one. And in practice, I don't think it's stopping anyone from writing good code. I think someday someone will sit down and actually write it, but it's not there yet. Yeah, it would be fantastic. If you're interested in that, if you're a GDB or LLDB pro, LLVM pro, then let me know and we'll get into it. Actually, that's the sort of thing that we might do as a final assignment in core school. That's a much harder, deeper problem than we'd be getting into here. All right, sometime tomorrow, I will send you the link to the recording, the homework, the lesson notes, all of that, and another link to the office hours as well. First office hours are going to be Friday morning, so watch for that. And hope to see you next week. Thank you all.